All right, we are going to go ahead and get started with matrices. So you're going to need to go to desmos.com/matrix and go ahead, go to this website, take a moment, get there while this video is running. If you're going to follow along with this should look very familiar. Whenever we need a matrix, we're going to click right here on new matrix and A will pop up. We'll put in the dimensions. It'll be great. Okay, in the meantime, while you're getting there, I am going to go here. And when I go here, that is going to take me to the review that we're about to do. So here goes. The data in the table below represent the number of students listed by gender and grade in a summer program. And we have males on the left, females on the right. There's just two slightly different shades of gray there, so you really can't tell the difference, but males will be on the left, females will be on the right. And we're going to organize the data into a matrix, but they're very clear with us about how to organize this. The rows should represent the grade level. So let's just stop and think about it. I have 4 grade levels, so I'm going to have 4 rows. So we're going to have freshman, sophomore, junior, and senior. And the column should represent gender, so we're going to have male and female there, and we need to figure out what goes in each one. We're actually going to call this matrix A, by the way. I didn't say that in the directions, but we're going to need that when we go here. So that's going to come in handy when we go to desmos.com/matrix. So here goes. I'll organize the data into a matrix. Freshman males, there are slightly below 15, and I mean slightly, so let's go with 14. Let's switch colors just for fun. Let's make it red. So 14 males, and almost halfway between 10 and 15, which means that would be 12 females. All right, sophomore males, a little more than halfway between 15 and 20, so 18. Exactly 15 for females. All right, juniors, a little more than 10, almost half for 10. Almost halfway between 10 and 15 is what I'm trying to say. Anyway, 12, you can figure it out. And then 10. Seniors, there are less. This is a summer program membership, by the way, in case you're wondering what I'm pointing at. Seniors, I believe that'd be 8 and 9. Okay, fantastic. What are the dimensions of the matrix? And the dimensions of a matrix, always rows and then columns. So this is a 4x2 matrix. How many sophomores are involved in the summer program? Okay, well, how many sophomores are involved in the summer program? Sophomores total would be 18 plus 15. That would be 33. This is easy. That good thing we have this information right here, right? Otherwise, you'd have to be like, that plus that. See, this is so organized. Matrices are fantastic. What percent of students are seniors? What percent? Oh, now here we go. Notice I haven't gone to desmos.com/matrix yet. And I won't need to actually for this. I will on the backside. What percent of students are seniors? Well, what percent of students? Oh, okay. So I'm going to write some stuff down that might kind of guide you in your thinking here. I need seniors as my numerator, and my denominator is just going to be total number of students. So I need to add all of these numbers. So 14, 12, 18, 15, 12, 10, 8, and 9. That is how many students that we have. So we have 98 students total, but then the seniors is going to be 8 plus 9, which is 17. So whatever 17 divided by 98 is, and it's roughly 17%. And we'll round it off to 17%. So 0.17, which rounds to 17%. So 17%, I say equals, technically it's approximate. We'll just go with it, okay? What percent of freshmen are female? We have to read these very carefully because when it says what percent of freshmen, then my denominator is freshmen. And the numerator is not females, but actually female freshmen. So female freshmen. So let's see, female freshmen, looking at my matrix here, is 12 out of the total number of freshmen, which would be 14 plus 12, which would be 26. And whatever 12 divided by 26 is, it's a little less than half. So 12 divided by 26 is going to give me 46. We'll call that 46%. I am going to approximate it. If you don't put the squiggly equal marks, it is okay. 46%. What percent of males are juniors? The denominator is going to be males. The numerator is going to be junior males. So let's see, males, total number of males is 14, 18, 12, and 8. 14, 18, 12, and 8. Oh, we can do that in our head. That's 30 right there. That's 44. 44 plus 8 is 52. So we have 52 males. Boy, I hope that's right. I'm going to feel ridiculous if I did that in my head and got it wrong. Now we're good. That's right. And the numerator is junior males. That would be 12. So 12 divided by 52. It's a terrible glare on this screen, isn't it? Let's turn the brightness down. Oh, that's better. That's much better. 12 divided by 52. And that's 23%. Whoops. 23%. There we go. I hope you're following along with what we're doing. I hope you're reading it carefully as you do this too, because it doesn't always say what percent of the total that is in this case, but not always. What percent of freshmen, the denominator is freshmen. What percent of males, the denominator is males. What percent of students, oh, that's the total number of students, are male sophomores. So these are going to be male sophomores. So the total, we already found that to be 98. The number of male sophomores, that'd be 18. So 18 out of 98. And I'll go ahead and tell you that it is super duper close to 18% because that denominator is super duper close to 100. Works that way. Okay, we're going to call this matrix A, capital A. What is little a 3, 1? What does it represent? Oh, now, what in the world? All right, this is the matrix. This is an element of that matrix. So the third row, first column. So just in case you're making notes here, this is row 3, and that right there means column 1. So row 3, column 1 of matrix A. So I'll just come up here and I'll look at row 3. Let's grab a pencil. It's for fun. Row 3, column 1. Oh, that would be 12. There you go. Row 3, column 1, that's 12. What does it represent? Well, 12. But no, don't just put 12, right? 12 male juniors. And then what is A1, 2? Okay, first row, second column. So now I'm looking here. First row, second column. That would be 12. So if I was to color the first row and color the second column, the only number I colored twice would be 12. So it's, well, 12. Again, lucky us. Same number twice in a row. Different representation, though. The first row represents freshmen. And the second column represents females. So 12 freshman females. There you go. Let's flip this paper over and keep going. Matrix A represents how many vehicles of each type were sold at a small car dealership in December. Very difficult for me to say. Matrix B represents the same type of data for the following January. Matrix C represents the commission that is earned on each vehicle sold. Whoa, what? All right, there's a whole lot of stuff going on here. Let's actually take a moment and type this into desmos.com/matrix. So let's go. Desmos.com/matrix is your friend. Matrix A is, and I'm looking at it on my paper while I'm typing it here. Whoops. I didn't mean to do that. Let's clear that. I need a new matrix, and my new matrix is matrix A, and it has 3 rows, 2 columns. You've been through this before. So 4, 0, 2, 4, 3, 3. There it is. And another matrix. We'll call it matrix B, and it also has 3 rows and 2 columns. It is 3, 2, 2, 3, 2, 4. And one more matrix. It's matrix C, and that is a 1-row, 3-column matrix. 1,200, 2,000, and 2,400. There we go. All right, now we get to number 10, and it says, what is A plus B, and what does it represent? A plus B. A plus B. Well, I can do this in my head. I mean, let's be real honest. I can do this one without really thinking too hard about it. But knowing that I have, all right, let's read the problem carefully. Matrix A is how many vehicles were sold in December. Matrix B represents how many were sold in January. Then A plus B, what does it represent? I'll go ahead and answer that. This is the cars sold in, well, January and December. That's the wrong order. December and January. And I'm actually not going to use desmos.com/matrix because I can do this one in my head. If I wanted to, I could simply type A, capital A plus B, and it would give me an answer. But let's just be really honest. Sometimes you can do it faster without that. So 4 plus 3, 0 plus 2, If you miss this, bless your heart. 2 plus 2, 4 plus 3, 3 plus 2, 3 plus 4. There we go. And if you want to get technical, I could label it. I could have cars. I could have trucks. I could have SUVs. Sounds like a car dealership commercial. I can have two-wheel drive. I could have four-wheel drive. I could have terrible handwriting. But total between January and December, or December and then the following January, I sold 4 two-wheel drive trucks and 7 four-wheel drive trucks. Okay. All right, what is 12A? What does it represent? Let's go ahead and talk about what it represents. 12A would be, well, 12 times A, and I actually can do this one without a calculator as well, and I just might. But what does it represent? Well, that's different. 12 times the month of December. So this is the sales for December multiplied by 12. Now, the question is, why would you do that? I would do that if I wanted to, I don't know, project what would happen for an entire year, and I'm basing it on my December sales. And again, I say December because that's what matrix A represents. All right, so what is 12A? 12A is still going to be cars and trucks and SUVs, and I'm not going to use desmos.com/matrix. Two-wheel drive, four-wheel drive. All right, and I will do 12 times everything in A. So let's slide this down just a little bit. 12 times 4, and so that's going to give me 48. Maybe I'm going to sell, this is a projection, 48 two-wheel drive cars. All right, and I will sell 0 four-wheel drive cars. And 2 times 12 would be 24. 4 times 12 is 48. 3 times 12 is 36. 3 times 12, 36. There we go. There's a good projection. All right, now things get a little bit tricky. What does CA represent? In order to actually answer that question to its fullest potential, I'm going to go about this a little bit differently. Well, C is commission. Matrix C is commission, and A is the sales in December. But let's break this down a little bit differently. In order for me to multiply it, this is going to be wordy. The number of columns of the first matrix have to equal the number of rows of the second matrix. So C is commission by vehicle type. All right, so check out what's happening here. The rows in matrix C is the commission. The columns represent the type of vehicle. All right, so now when I multiply it by A, I'm going to have rows, which is the vehicle type. So I'm going to have, we'll multiply that, put the dot there for that one, vehicle. And then two-wheel drive and four-wheel drive. So I'm just going to put drive, drive type. Okay, well, if everything works according to plan, and it will, these, in a matrix multiplication kind of way, will cancel out, and I'm going to have commission and drive type. So the amount of money that the salesmen and saleswomen make on the car based on the type of drive. And I'm actually going to go ahead and write the explanation. That was part of the explanation, sort of making sense of it. And this is the commission earned based on two-wheel drive and four-wheel drive. And let's look ahead. Okay, I still haven't answered the question in terms of what is CA like. In a minute, I'm going to get an answer that is a matrix. And this matrix is going to be, let's go ahead and go here. My matrix is going to be a, let's see, this was a 1 by 3 matrix multiplied by a 3 by 2 matrix. So I'm going to get a 1 by 2 matrix. So in just a minute, I'm going to figure out what that is. There's a way to do it by hand. We're not. But for the next one, what is C times A plus B together? And this is going to be the same idea. This is the commission earned based on two-wheel drive and four-wheel drive for December and January. And this one was just for December. Okay, so what we're going to do is go ahead, type these things into desmos.com/matrix. It's going to be super easy. Then we'll get to some of these down here, and they're a little bit different. All right, here we go. Let's see, we're going to type CA, and there it is. It cranks it out for us. There's a way to do it by hand, but we're not going to. So what you see on the screen right here, where my mouse is, right there, I'm going to write that down as my answer on my paper. I know you can't see my answer right now, but 16,000 and 15,200. And then I'm going to do the exact same problem, in a sense. It's going to be C times, capital C times A plus B. There we go. And I'll have that answer as well. We'll write that one down. And 28,400, and then 33,200. There's that one. Okay, let's go back to the paper for just a moment. And here is what it represents. This is the commission I earned, and this is two-wheel drive. This is four-wheel drive. This is two-wheel drive. This is four-wheel drive. And this is my commission. And this is my commission. So I'm a salesman, and I earn commission. And in my commission, I can earn money based on two-wheel drive cars or four-wheel drive cars. This is what happened in December. This is what happened in December and January. All right, let's shift gears a little bit here. And we're going to go to some Math 1 that you never learned how to do in Math 1. You didn't learn how to do it this way in Math 1. What we're going to do is put everything, all four of these problems, in standard form. I'm going to actually just jump through that and do that first. So we're going to take this and write the x first and then the y, and it's going to equal a number. So here goes. That negative 9x, I'm sorry, is in the wrong place. It's going to move to this side, and that's going to be 9x minus 6y equals negative 12. I know this is a huge transition from what we just did. I realize, like, it's a major jump from here to here, but we're going somewhere with some of these. All right, the second equation is 8x, that sounds good to me, equals 5y. Oh, we have a problem. Okay, so here's the deal. Here's where I'm going with this. Every one of these has to be set up as x, y equals a number, or in this case, x, y, z equals a number. Okay, so x and then y, this is going to move over. We're going to put it over here, and it becomes a negative 5y, and that equals negative 8. And that is fantastic and wonderful and good. So I'm going to hold that thought, and I'm going to come to this one. All right, so here's the next one. X, y equals number. Oh, the x is in the wrong place. We're going to move him over. And when I do, it becomes negative 1x plus 1y equals 10. And then x, y equals number. Yeah, we're good. Negative 9x plus 8y equals number. Okay, and we're moving on to the next one. X, y, z equals number. Check. Good, good, good. X, y, z equals number. Check. X, y, z equals number. Check. These are actually called, in a very loose sense, called standard form. There are exceptions to that, but for now, we're going to call it standard form. Standard form can be wacky at times, but this is going to work for us. All right, I'm changing colors just for fun. We're going to write these as matrices, all three of them, then we'll do this word problem down here. So 9, negative 6, 8, negative 5. We have two equations and two unknowns, so we're going to have a 2 by 2 equation here. And then x, y. And the beautiful thing about this is that if you were to use matrix multiplication that we have not done by hand, you would end up with this equation right here. So then we have negative 12 and negative 8. What am I doing? I'm setting up a matrix equation. This right here is my matrix equation. I'm going to write that down. So matrix equation. Why do I do that? Because it helps me solve this very quickly. Otherwise, we'd be doing this by hand, right? And nobody wants to do that right now. All right, let's set up this next one as a matrix equation. Negative 1, negative 1, negative 9, positive 8, x, y. There we go. 10, 64. Done. Now we're not done with the problem. I'm doing all three problems in pieces. Okay, let's go to the next one. Negative 10, negative 4, negative 3. Oh, three equations, three unknowns. That we're going to have a 3 by 3 matrix first. 6, 4, 1. Notice the 1 there. By the way, if there's something missing, like if I didn't have a z, it'd be a 0 right here. 9, negative 4, negative 2. And then x, y, z equals negative 5, negative 9, positive 2. There we go. All right, changing colors again just for fun. This shall be matrix A. This shall be matrix B, and my final answer for any of them is what I would get if I divided by A. Okay, so if I wanted to know what this is, I would divide by A, but here's the catch. You can't divide matrices. I tried it one time. I ended up in the hospital. It's not worth it. So you need to instead do what you can do when you can't divide. You actually multiply by the inverse. There's a way to find the inverse of this matrix by hand. It's beautiful. It's wonderful. It's not the point of this lesson, though. I'm going to do A inverse B, and whatever I get is going to go right here. And that's going to be my answer. So xy equals something, and that's going to tell me my x value and my y value. Same thing here, xy, and it's going to equal something. And this one's going to be xyz, and it's going to equal something. I don't know what it is. So we're going to type the stuff into desmos.com/matrix, and we're going to go from there. Let me put this calculator down to kind of hold the paper in place. I'm going to type these in. I'm going to go very fast on this and hunker down. Here we go. First of all, I would like to clear and clear all. And so I have a new matrix. I'll call it A, and it is 9, -6, 8, -5. There we go. Whoops. New matrix, and it is B, and it is a 2-row, 1-column matrix. So we're going to have -12, -8. There we go. And I need to find, here's where I am. I have typed that one in as A, and that one in as B, and I'm going to find out what that is by typing A inverse B. So let's do it. Watch where the mouse goes. A. Watch the mouse, watch the mouse. Inverse B. Boom. You see the answer? 4, 8. X is 4, Y is 8. It's that simple. It took a few steps, but it's that simple. So I'm writing it on my paper. You can't see what I'm writing, but I'm writing it. Trust me. There. Now you can see it. I'm going to do the same thing for this one. I'm going to do the same thing for this one. And in order to do it, actually, to speed things up, I am going to type them in a little number pad that I have here. It's going to make life much easier for me. I can type it faster on this than I can on the regular keyboard. So I'm going to go fast. Now, I recommend actually that you kind of mute the video and you try these on your own on Matrix, desmos.com/matrix. I recommend that very highly because I'd hate for you to get somewhere in some problem and be like, man, I wish I would have tried this on my own and worked out the kinks. Okay, so give it a shot just to make sure you know what you're doing, even though you may have already done it before. It might have been a while. So let's clear all. I'm doing the second problem. I'm probably not going to say much, so the video is going to get super boring right now. Actually, right now. Please don't just copy this. Please, please, please don't just copy this. All right, we have a problem. I have decimals, and that is totally okay to have decimals. That either means that the answer has decimals or you messed up, and decimals happen in the real world a lot. So in this case, well, we're good. Let's see. Yep, they are indeed decimals. I'm actually going to turn them into fractions, which is the thing. Let's do it. Yeah. -144/17. Now let's switch from decimals, from fractions back to decimals. I just like them better. So -8.47 and -1.53. I like to round things. There we go. There it is right there. And we'll do the next one. Go. Got it. There we go. I found my answers. That one had decimals, but that's okay. We'll get over it. And this one, in this case, you care. X is 0, Y is -4, Z is 7. And let's move on to the word problem. This is going to be last thing we do on this video. The admission fee at a small fair is $12 for children and $15 for adults. And on a certain day, 2,835 people enter the fair and 38,886 is collected. Okay, let's just go ahead and be real honest. Everybody is either an adult or a child. We have children, we have adults, and the total number of children and adults together is 2835. Okay? And now we'll keep reading and we'll underline all the money, and this money is going to go together as well. So it's $12 per child and $15 per adult, and we had $38,886 that came into the fair that day. All right, well, that is fantastic. Why don't we solve this thing using inverse matrices? So let's start by making a matrix equation, which means we're going to have 1, 1, 12, 15, 1, 1, 12, 15, and then C, A, children and adults, and then 2835, that's the total number of people, and then 38885, that's the total amount of money. As with the last problem, we'll let this guy be A, we'll let this guy be B, and we are about to find out how many children and how many adults. So child and adult, and we're about to get a number. And by the way, in case you care, when you're done with this problem, these two numbers had better add up to be 2,835, or we've done something wrong. So let's start typing. Go into the website. That website. All right, new matrix. 2 by 2, so 1, 1, 12, 15. And new matrix. Matrix B is a 2 by 1, and it is 2835, 38885. And we'll do A inverse B. And something is wrong. Oh, I know what the problem is. I know exactly what the problem is. Here's the problem. My bad. Sorry. That's 38886. I was going to say we can't have decimals when it comes to people. 38886, not 38885. Problem solved. There were 1,213 children, 1,622 adults. There they are right there. That's it.